Hello everyone, today in this video we'll be discussing the SQL queries, minimal cover and serializability questions which were not discussed in the other videos. So along with that I'll be discussing what all you need to focus more on and how you need to solve the paper, what will be the exam paper pattern, and yeah, those things we'll be discussing. And this video is going to be long, I'm not sure, but I'll be trying to put up all the points what I have to tell in this video. And see, first of all, DBMS is a cakewalk. Okay, it's not at all hard subject if you understand the pattern of how the questions are asked. Okay, so since the time is less, if you have not studied anything also, you still have time. Don't lose the hope. I'll tell you what all you need to study and how you need to study. And before starting, if you like this video, please hit the like button and don't forget to subscribe to my channel. And if you have any doubt of any question you need the answer, DM me on Insta. I'll be trying to reply you in that there I'll be trying to reply you. And in this video I'll be just covering a few questions, the overall pattern of how to answer the questions. Okay, so see, the syllabus of 18 CS53 DBMS is not unlimited. Okay, it is a limited subject. We only have 5 modules. Okay, so first remove that concept from your mind that the syllabus is not going to over. And there are 5 modules, and the module 1 is full theory. And coming to module 2, we have the theory part as well as the SQL part. Okay, so for module 1 we have the theory, full theory. There are just 5 or 6 concepts. Okay, go and memorize that, go and learn that. Okay, don't ask me what are the important questions in that as well. Okay, theory concepts you can learn it easily. Okay, and coming to module 2 and 3. Okay, in module 2 and 3, except the theory concept, I'm just talking about the SQL part. Okay, there are SQL queries which you need to solve. Okay, if you get to know how actually you need to solve the query, there is a step-by-step method which if you follow you can easily solve the SQL queries. So that I'll be discussing using 2 or 3 questions. Okay, and except those questions, if you have any other questions like you want the answer or help from me, you send that answer, send those questions to me on my Insta account. Okay, and that was about module 2. The theory things are there and the SQL queries. Okay, means for both module 2 and 3. And coming to module 4, this is the thing. See, in module 4, firstly you have the theory concepts, just 5 or 6 questions that are the theory things like what is normalization, 1NF, 2NF, 3NF, what is functional dependency, multi-value dependencies, and there are few more questions. Okay, that same questions which I have put in the PYQ video. Okay, so learn them, and after that what the numerical things that might be asked are, there are 3 algorithms. Okay, that I'll be discussing what are the 3 algorithms as well as the problems based on it. Okay, the 3 algorithms and problems based on it, how to solve that one. Namely, they are, the first one is the closure. What is the algorithm for finding the closure? What is the how do you find the closure? The question can be directly asked, find the closure for the following functional dependencies. That's the first question about closure. Okay, the next one is the minimal cover. If you know to find the closure, you can move to the minimal cover. Okay, there you will be finding the minimal cover and you will be writing the algorithm for it. That's the second question. And the third question is the lossless join. Okay, lossless additive join property, in that the algorithm is there as well as the numerical is there, but focus more on the minimum closure. This is the most important among these 3. So I'll be discussing a few problems on these 3 topics, as well as after that we have the normalization questions. Okay, means they can ask you, they will give you a table and the dependencies, and they'll ask you to normalize up to 2NF or 3NF, or they'll ask you to find the primary key, which are the candidate keys, those type of questions. Okay, we'll be discussing that as well. So that's all in the module 4 about the normalization and the minimal cover things. And coming to module 5, the algorithm is just one algorithm, like it's rarely asked. Okay, like serializability, how do you test the serializability? That's the module 5's numerical question. And the serializable means they will be giving you some data, and you have to find out if the thing is serializable or not using a precedence graph. Okay, you have to make a graph and do that. So don't worry about anything, I'll be discussing all these things, how you need to solve. And the main question is whether you need to, if you can skip these things still score good marks. See, what is the thing is, in one module these questions can come like 10 to 15 marks. Okay, so if you lose those 10 to 15 marks totally, in the theory you should be very very good. Okay, means you should score out of out in that theory part. Okay, all the theory parts, if you score out of out, then hopefully you might get the passing marks. Okay, because 30% of the questions are these topics only, and these are very short answer types, but if the answer is correct you will get very more marks you will get. Okay, so firstly, whenever you get an or option, okay, that's the first strategy. If you get the question here, you have a question, okay, for example question 5 and question 6, okay, you have an or here, and wherever you have the theory part, go for that. Okay, if you're not sure about the numerical part, go for the theory part. That's the first thing you need to check, whether there is an or question in the theory or numerical. If there is a or question, go for the theory part. Okay, that's the first thing which you need to keep in mind. Okay, so let's get started with the module 2 and 3. Here we have the SQL queries. Okay, so see carefully what is the type of the question. Okay, this is from module 2, I guess, but it does not make any difference because module 2 and 3 are very similar. So let's see how to solve the queries question. Okay, see what all they give. First you note down that works, p name, c name, salary. P name is the person's name, c name is the company name, and the salary. So a person works and his p name, person name, c name, and salary, company name. Okay, and lives, where he lives, this data is given, located in, and manager. So how many tables are there? 4 tables: works, lives, located in, and manager. That's the first thing which you need to observe. Okay, the second thing is that come to the queries, count how many queries are there. 5 queries. Okay, and the total marks are 10. So for each query you will get 2 marks. Okay, just the query is like 1 or 2 lines. See, for 1 or 2 lines, if you write like for 5 things, how many lines you wrote? 10 lines. For 10 lines you got 10 marks. But if that's the theory thing, how many lines you have to write, how many pages you have to write to get the same 10 marks? So I tell you, get the pattern and the technique to solve these questions. It's very simple. Okay, so after you have noted down what are the tables, you have to move on to the solution. I'll be discussing 3 questions here, and to means make you understand what is the actual pattern you need to keep in mind. Okay, now see here, in after going through the table, you have to make like this. Okay, like the schema diagram. Works, you have the p name, c name, salary, and for the lives and located in and manager. That's the first thing which you have to make. This is not compulsory, but this will help you to means derive the query for it, means in an easy way. Okay, so let's see what is the first question which is asked to us. The first question is, find the names of all persons who live in the city Bangalore. Okay, you need to break down this question. The first thing which you need to do, find the names. What you need to do, find the names. Okay, this is the first thing which you need to focus on. Find the names of all person. This is the second part. Find the names. So name, where all you can find the name of the person. You have works and lives. So 2 places you have works and lives. So these are 2 tables which you will be considering. Okay, and of all persons who live in the city Bangalore, then what they are asking, live. So they are mainly focusing on this table. So you need to eliminate this table. You just focus on lives table. Live in the city Bangalore. What is the condition? The city's name should be Bangalore. Repeating once more, find the names of all persons who live in the city Bangalore. Name, you have selected this one. All persons who live means this table, and the condition is city is Bangalore. So first what you have to write, select what you need, names. So select names, select p name from which table? Lives table, where city is equal to Bangalore. Okay, so that's all what you have to write here. Select p name, okay, from lives where city is equal to Bangalore. Okay, that's the first query. That's how you need to approach each of these questions. Okay, let it be any question, you will approach in the same way. Next one is, retrieve the names of all persons of Infosys. This is the secondary part. The first part is retrieve the names of all person. So again, these 2 tables are getting considered here. Of all persons of Infosys. Infosys means it's a company. Company is in which table? This table. So here you will be considering this table only. Okay, and whose salary is between 50,000, means less than 50,000. Okay, so you will be considering just this one. This is the condition. Last thing is always the condition. In the first thing you will be considering which is the table you have to select, and you will be writing the query. So retrieve the names. Select p name. Oh, sorry, not this one. Select p name from works where company name is equal to, c name is equal to Infosys, and salary is less than 50,000. Okay, that's what I have written here. Select p name from works where c name is equal to Infosys and salary is less than 50,000. Okay. Then the third question. In the third question, find the names of all employees. Find the names of all persons. Find the names. Names means these 2 tables. Who live and work. Live and work means these 2 tables are getting considered in the same city, where city is same. Here the city is same, and since the city name is not here, through c name we have to find out which city it is located in. So we need these 3 tables. First, how we will start? Find the names. So select p name from any of these 2 tables you can select. Select p name from lives where p name means live.city. Okay, live.city is equal to this one, work also in the same city, right? How you will select which city it is same as? You will select located in city. Okay, located in city same as lives in city. Okay, see, let me make it clear. First you will start from here. Find the names of all persons. Select p name from lives. Okay, select p name from lives and works located in. These three tables we are considering. So we have written select p name from lives located in and works where works dot p name is equal to lives dot p name to connect these two tables, and after that where works dot c name is equal to located in dot c name to connect these two tables. At the last you will connect where lives dot city is equal to located dot city. So these three tables are connected. So which the city name is same and the person's name is same as well as the company name is same, those rows will be selected. And what we are selecting, not the whole row, only the name. So that's what we had specified earlier. Whatever we need to select, that we have to specify first. So we have written l dot p name from works w, lives l and works in I, where w dot p name is equal to l dot p name to connect w and l. Okay, to connect w and l, these two. After that what you will connect, this and this. Why we are considering located in? Because we need city. After you have connected these two, like works dot c name is equal to located in dot c name, after that lives dot city is equal to located in dot city. Okay, these three conditions you specify. Okay, so that was about the third query. Let's move on to the fourth one. List the names of the people who work for Tech M. List the names of people who work for. So which table you are going to consider? This one. Who work for Tech M. Tech M is C name, where C name is equal to Tech M along with the cities they live in. So to get the city name, what we need is where they are living along with the cities they live in. What they have asked, along with the cities they live in. Okay, so live city and this one we have to connect. How we will connect is p name through p name. Okay, so select the names w dot p name from works w lives l, where works dot c name is equal to Tech M. First we are considering the first condition, which is the company name is Tech M, and lives dot along with the cities, right? We just have to retrieve lives dot city also. Okay, where lives dot p name is equal to works dot p name. So if I show you the query for the fourth one, select l dot p name from works w lives l as well as city l dot city. Okay, two things you have to retrieve, where the person is living as well as the person's name, l dot p name and l dot city. From which table? From the lives table. We need works w for the condition, so I have written works w also, where w dot c name is equal to Tech M, the company name is Tech M, and w dot p name, the works table's person name should be equal to the lives table's person name. Okay, that was about the fourth query. The fifth one is find the average salary of the Infosys person. What we need to find? Average salary. How we will find that? AVG salary. Find the average salary of the Infosys person. How we will know the person is working in Infosys? Which table we have to consider? Works. Select average salary from works where the works.c name is equal to Infosys. Okay, simple, right? Select average salary from works w where w.c name is equal to Infosys. If this is clear, we can move on to the second question. Here the company database is asked and we have how many tables. See, what is the first step? You have to see how many tables are there. How many tables are there? 1, 2, 3, 4, 5, 6. 6 tables are there. That's the first point. Second point is go through all these things. Name, SSN, salary, super SSN, D number. So like that you can read all this and get to know what is the overall concept. Okay. The third thing is you have to make the schema diagram. Okay, so if I make the schema diagram here, just the same thing in boxes we have to make here. After we make that, we'll be starting with the queries. Okay, so in the queries what we have, the first query is retrieve the names of the employees who work with the same department as Ravi. So what's your first step? Retrieve the name of employee. So which table you are going to refer? Where all you can find the name? You can find the name here, D name, P name, project name and name. What we need? The employee's name, right? Name of the employee. So which table we are going to refer? Employee table. Okay, so here we have retrieve the name, means select name from employee who work with the same department as Ravi. So how do we know which department Ravi is working in? By using the same employee table and the department table, because in department table we have the department number and department number connects the employee thing also. So select the select D number. Okay, listen to me carefully. Select D number, select the department number where name is equal to Ravi. Select the department number where name is equal to Ravi. So what will be selected? Which department Ravi is working in. If you select the department number from name is equal to Ravi, you will be getting the department number which Ravi is working in. Now you have got the department number which Ravi is working in. Now what we will do with this? By using this, we have to select the names of employee who work in the same department. So after selecting this one in a nested query, what you will do is select employee name from employee where D number is equal to this one. Okay, so first we will find this, then we will equate this. First we will find this, then we will equate this. So let's see the two things. First we will find and equate also. Okay, so how we will find this? Select E name, employee name from employee where the employee's department number is equal to, means in we will write, okay, for equals symbol. In select department number from employee name from employee where department name is Ravi. From the name is Ravi. So wherever name is Ravi, what is the department number, that will be selected, and the department number selected will be written here, and the same department numbers wherever it matches, those E names will be selected. So that's all we needed, the employees who work on the same department as Ravi. Okay, that's how you approach this question. The next one is retrieve the names of the dependents for an employee Ravi. First thing what we need to retrieve the number of dependents. Number of dependents means what? How many? Count. Okay, so first we need to retrieve the count. So what we will be writing here is the first thing as select count star from which table? Dependent. Okay, so that's all for now. Count star dependent. Next, let's see what they have asked. For an employee Ravi. So Ravi is here. Ravi is an supervisor and he has dependents. Okay, so there are 3 dependents for Ravi, and what we have got is count star dependents of whom? Ravi. Okay, Ravi is the supervisor. So in the table here which they have given us, how can we connect the dependents table and the employee table? Because name is written in the employee table, whereas in the dependents are written in the dependent table. So as you can observe here, ESSN is nothing but the employee SSN of whose the dependent is. Okay, so if Ravi is here, Ravi has dependents, Ravi's ESSN will be written here and their dependent names will be written here. Okay, like that. So ESSN should be matching of Ravi. So we have to match the SSN of Ravi in ESSN, where ESSN is equal to, like that we have written here. Select count star from dependent where ESSN, the SSN should be what? Ravi's SSN. So first we need to get Ravi's SSN. So in that we will write in the brackets what we will write, select SSN from employee where name is equal to Ravi. So here we will get the Ravi's SSN and that will be matched here, and how many dependents we get a match here, that count will be displayed in the answer. Okay, that was about the second one. And coming to the third one, retrieve the names of managers working in location Delhi who has no female dependents. Retrieve the names of managers. Names of managers, in where you will get the name of manager. Here you will get the manager SSN, but the name will always be in the employee table only. So you will have to retrieve the name from the employee table. So what will be your first query? Select name from employee. Okay, select name from employee, that's all. Okay, select name from employee. Select e.name from employee E. Now what they have asked, let's move further. Next part they have asked for managers, for the managers working in the location Delhi. How we will get to know that the person is a manager or not? The person is a manager only if the employee's SSN matches the manager SSN. Okay, the employee's SSN matches the manager SSN, then that employee is called as the manager. Okay, so that's the second thing, we need to focus on the manager part. So here what we have, department D, department location L, where E.SSN is equal to D.manager SSN. Employee SSN, if it matches the manager SSN, that's the first thing. Okay, so after we have got that manager, we have got till now we have selected the managers of all the departments, but we only need the department which is working in which has the location in Delhi. Okay, so we have selected this manager SSN and SSN here. Also along with that, we need to join these two tables. These two tables are joined by the same attribute, which is the same attribute d number. By using d number, we'll join this, and manager SSN is equal to ESSN. So two things we have written here, to join the table and to write the ESSN. So E dot SSN is equal to D dot manager SSN, and D dot D number is equal to DL dot D number. Okay, sorry, not the employee. We will be matching this one, department location and department, because the condition given is location Delhi. Okay, so we'll be matching these two, where D number is equal to the D number in the D location, and finally we'll write D department location is equal to Delhi. So the third condition is that department location is equal to Delhi. After we have written that, the final condition which is given to us is who has no female dependents. No female dependents means where not exist will use. Wherever they ask not female dependents, like that question will come, you have to write where not exist. After writing not exist, you have to select all those that exist. I'll repeat. First you have to write not exist. After that, here you have to write all that exists. Why? If all the exist come here and you take the not operator of it, you will get that which is not of this one, means no female dependents. If you select all female dependents here, then you do the not operation, the answer will be no female dependents. That's what we want, isn't it? So here you will be selecting star, means all the rows from dependent D, where D dot ESSN is equal to E dot ESSN, means the dependent table as well as the employee table we are matching. Okay, and D dot sex is equal to F. So the females means who are all female dependents, those persons will be selected here, and the not will be applied to here. So we will have all those dependents who are not females, and that condition will be applied, and only those rows will be selected in this condition. Okay, that was about the third one. And coming to the fourth one, list the female employees from D number is equal to 20 earning more than 50,000. What you have to select? The female employees, means the names. So where will you get the names? Name will get here in employee. Select name from employee where D number is equal to 20 and salary is more than 50,000. So that's all what you have to do. Finally, list the CSC department details. Select the department list the CSC department details, right? So department details, which table you will get? Department table. Select star from department, where D name is equal to CSC. Okay, so that's the final two queries which you have to write. Okay, easy. The next one is about the employee table and the department. Here also it's a similar one, but a slightly different one. Okay, it's also repeated question. Okay, so one more thing I forgot to tell you, if you get the relational questions, relational algebra or the SQL, okay, two types of questions you can get. Whenever you get those questions, means relational algebra is a slightly harder concept, at least for me. I could not understand it in a simple way. So do one thing, if you get the OR question, go for always SQL. Okay, SQL, which question is there, if you get OR here and here, go for that question only which SQL is there. Okay, don't go for relational algebra, skip that. Okay, so let's resume the question here. So the question is that what is the first step? You have to write these tables here, make the schema diagram. Second thing, retrieve the name and address. Now you can only say, okay, answer me, what all you need to retrieve? Name and address. Name and address is in which table? Employee table. So what you need, select F name and L name, comma address from employee. First step is done. Who work for the research department, where department name is equal to research and department dot D number is equal to employee dot D number. You have connected these two tables and specified the name as well. That's the first query. The second one is make a list of all project numbers. What you need to make a list of project numbers. Where do you find the project numbers? Which table it is? Project table. So select P number from project table that involve an employee whose last name is Smith. How do you connect the employee and the project number? Employee and the project number are not directly connected, but through the works on table. In works on table, you have P number here and it's connected via ESSN. By ESSN, you will be connecting the employee. So what are the steps? Select P number from project, where P number is equal to P number from the works on table, and works on ESSN is equal to employee SSN, and employee last name is Smith. Okay, that's the first thing which you need to keep in mind. And let's see the query. You will have more idea of means you'll get a clear idea of what you need to exactly do. Select P number from project department employee, where D number is equal to D number, department number is same, and this for the manager, because the question what they have asked is either the person who is the working in that department or managing that department. So two things are there, working and management. So we'll find out those two answers, and then finally we'll be doing the union. This for the workers, this for the manager. Let's discuss the workers part first. So here project department employee, P number is equal to P number, the works on table and the project table is getting connected, works on table and the employee table is connected, and employee table last name is Smith, that is getting connected. So those P numbers will be selected. And finally we need the manager also. So who all manages the department? The manager, SSN. Connect the department and SSN table, and department number and D number, these two tables, the project and the department table you are connecting. After that L name is equal to Smith, so where last name is equal to Smith, those managers working in the same department of that same project, those are getting selected. So managers as well as workers, select and do the union. Okay, let's move on to the third query. The third query is to list the managers who have at least one dependent. So list the names of what? List the names of whom? Managers. So managers name comes in employee. Select F name, L name from employee, where then we will see what is the next part of the query. This is the first part. Select F name and L name from employee. That's the first step. Then where exists, who have at least one dependent, right? So where exists, select star from dependent where SSN is equal to ESSN. Dependents dependents ESSN. The dependents supervisors SSN is written here. If that is same as the SSN which we are considering here, then select it. And exist, select star from dependent where SSN is equal to manager SSN from department. Okay, so firstly we are considering from the dependent, and second from the department. In the department, SSN is equal to manager SSN. Okay, coming to department here, in the department the employee is here. You have to confirm, right, if the employee is truly a manager or not. Okay, so the employee SSN, if it matches the manager SSN here in the department table, then that person is the manager, and under the manager the dependents are there. So in the first only you had connected the employee table along with the dependent table. So dependent is here, the dependent supervisor SSN is here. If this is matching with this one, then we are selecting that. Then we are confirming if this is the same as the manager or not. Okay, so we are selecting the dependents who have at least one dependent from both the tables, like the department and the dependent. So why we are considering the department also is because it's not that the employees dependent, it is a manager's dependent. So we just need the persons who are managers, their dependents. That's why we connected this one and this one. The next one is a pretty simple one. Find the sum of salaries of all employees. Find the sum of salaries. Sum of salary, how you will find out? Sum salary. Okay, the next is maximum salary, minimum salary, and average salary. So those are the aggregate functions, easily you can write. Let's see what is the answer. In the answer we have sum salary, max salary, min salary, average salary from employee. That's it. Last one is about for the each project, retrieve the project number, project name. See, for each project, retrieve what? Project number, project name, and the number of employees. So project number you'll be retrieving from here, P number, P name, and the number of employees. How you'll be retrieving? You'll have to connect the project and the works on table and do the count star. Okay, so let's see what we exactly have to write. So in the answer part, P number, P name, and count star. Count star is for the number of employees from project and works on, where P number is equal to P number and group by P number and P name. Okay, so which two tables we are connecting? These two, works on and project, where P number is equal to P number, then group by P name and P number, because what we need is the persons working on which project. So how many this is the project 1, project 2, project 3. In this, how many persons are working? What are their names? How many persons working? What are their names? So this is the project name, project number. In that, how many employees are there? So we are grouping this by the project number, project name, and how many count is there, that will be displayed here for each of these project which are getting done in the department. Okay, So this were the three questions from the model question paper which I have discussed, like giving you a brief idea of how to solve the questions. Okay, if you have some questions which you are not getting the answer, or if you need help, send me the questions in the Insta. I'll be trying to reply you. Okay, that was about the module 2 and 3. Except the theory part, these are the type of questions which could be asked in exam. Okay. So let's move on to the next module, which is module 4. Here two things we have: algorithms and problems. Okay, algorithms and problems and normalization questions. Okay, so what is in the algorithms and problems? 3 algorithms are there. We'll be discussing that at the end. So let me show you what are the 3 algorithms. The pic is not clear, but you can get it the same thing to the notes. So the first, this is the lossless joint property. Okay, third algorithm. Okay, this is the algorithm which you have to write, and what numerical they have asked, you have to answer that. Okay, there are 5 steps in it. And the next algorithm is the finding the minimal cover. This is the algorithm, 4 steps are there. And the third one is determining the closure of f. Okay, this is a small algorithm, easy one. Okay, so these are the 3 algorithms which you need to memorize, and based on these 3 algorithms there are few questions. So let's discuss what are those questions. And along with that, these are the algorithms and the questions part. Along with that, we can expect the questions from normalization as well. Okay, so these are just few questions to give you a brief idea of how to solve the questions in each topic. Okay, these are not the important questions or something. This is just for giving you a brief information, like how to solve the question. Okay, so let's get started. The first problem which we'll be considering is find the minimal cover. Okay, so this is the question number 7. So here is the question number 7. The question is like this. This is a repeated question in the previous questions. A relation R. So first you need to consider which is the relation given to us. How many letters are there? A, C, D, E, H. Satisfies the following: functional dependencies A to C, AC to D, E to AD, E to H. A to C, AC to D, E to AD, E to H. Okay, find the canonical cover of this set. Canonical cover is nothing but the minimal cover. Okay, so how do I approach this question? Okay, to find out the minimal cover, you have to first know how to find out the closure. Okay, for the closure I am not considering any separate question because it's very simple for find the closure. So how do we find the closure is, for example, these are things they have given. I'll be writing the same things here as well. So let's discuss here only. This is the question given to us: R value and the functional dependencies. Now the first thing which you need to know is how to find the closure. Okay, let me consider the closure of A. Closure of A is written as A plus, that is equal to, from A where I am reaching, from A I will reach obviously, A to C, so C I am reaching, then A is going to, AC is going to D. Okay, so do I have AC? Yes, I have AC, so it is going to D, so I will be writing D here. Now from C I am going somewhere? No. From D I am going somewhere? No. So this is the closure of A. So you will be understanding closure in a separate question, which is I think question number 8. In the next question I will be discussing how to find out the closure. Now focus on the minimal cover. Okay, so in minimal cover, first step what you have to do is the RHS should have a single attribute. RHS is this one. This is RHS, 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 RHS. The first step is you need to see the RHS has single attribute. Here does it have single attribute? No, it has 2 attributes, right? AD. So you need to make it as a single attribute. What you will be doing is decomposition. E goes to A, E goes to D. Okay, so that was the first step. After you have all the single attributes here, that you will keep it as such. In the left part you might have 2 attributes, so for now it doesn't matter much. Okay, so just keep it as such. So in the second step we will be considering each of these: first, second, third, fourth and fifth, and removing the redundancies. That's your second step. After you have written this one, consider each one by one and remove the redundancies. What is a redundancy? How do you remove it? Let's discuss that. So here A to C is the first thing. So in the A to C you will be writing here A to C, and except A to C, what are the rest of the things that you will be writing? These are the rest of the things you will be writing here. Okay, so after you have written that, find out the closure of A. See here, except this one. Except this one, you have written all these things here. Now first you will be starting from here. It is A, right? So you will be finding out the closure of A. What is closure of A? A only. Initially it is A only. Okay, now seeing here, where all you can find where A goes to. Here AC goes to, we can't consider. Here E goes to, no. E goes to, no. E goes to, no. You don't have anything, right? So only A is there. Now what is the answer you got? Only A. But I need C. Why I need C? Because here C is there. I need C here. Okay, I need the answer C here. I didn't get that answer. So what I will do? We are not reaching C, so we can't eliminate A tends to C. Understood? So if you did not understood, please means loop it back and watch this again, this part again, so you'll get a clear idea. Okay, so I'm moving further now. AC goes to D. The next thing you have to consider, AC goes to D. Okay, AC goes to D, you will be writing here as such, same. AC goes to D, and except AC goes to D, what are the things here? Except this one, these are the things which you will be writing. Okay, these are the things which you will be writing in the bracket. So I've written these things in the bracket. Now AC goes to D, write AC here. AC where it goes? A and C. Now from A, I am going to C, that's already written here. A I am going somewhere? No. C I am going somewhere? No. So this is the final step. But I want D. My target is I want D. Did I get D here? No. If I did not get D, we can't remove AC goes to D. Similarly, in the second one, E goes to A will write, the rest of the things will write, and we'll write closure of E. Closure of E is E itself. And from here I am getting E goes to D, I'll include D here. E goes to H, I'm including H here. Did I get A? No, so I can't remove E goes to A. E goes to D, right here the same things. E goes to E itself, then from here I get E goes to A, E goes to H. Now after that E's part is over. Which are the new letters I got? A and H. Does A go to somewhere? A goes to C, I'll write C here, and AC. See, A and C I got combination. AC goes to where? D. So I got D here. Now tell me, did I get D? Obviously I got D, so I can eliminate E tends to D. This will be eliminated. If this is eliminated, from the main answer we'll be writing here, E goes to D, eliminated. So next step is to consider E goes to H, and the remaining things are, we'll just consider these two. This is eliminated. We need not consider that, okay? So these three things you consider. So we'll write E goes to H here, and after that we'll be writing these things here, and E goes to H, right? So E goes to E itself, and after that what we have? E, okay, and E goes to A is written here, so I'll write E goes to A here. A goes to C, so I'll write C here, and I have AC here, so AC goes to D, so I'll be writing D here. Now tell me, did I get H? No, we did not get H, therefore we will not eliminate E goes to H. So what is the final answer which we got? These are the four things which you have in the final answer. A goes to C, AC goes to D, E goes to A, E goes to H. So after that, your third step is to come to the LHS part. LHS part, how many letters you have? 2 letters. So you have to decompose it. A goes to D, C goes to D. Again you will do the same thing. A's closure is AC. See the above things and write the same thing here. A and C, A goes to A itself, and A goes to C I have, so I have written C here. Now C goes to somewhere? No. A goes to somewhere else? No. So we'll be just writing AC. Did I get D here? No. I can't eliminate A goes to D. Same thing for C also, I can't eliminate C goes to D. Therefore my answer remains the same, AC goes to D in the third step. Now combine these things. If we combine this, what you can observe is A goes to C, A goes to C, and C goes to D. Individually consider. C goes to D, A goes to C, C goes to D. Isn't it transitive? We can directly write A goes to D, right? Also, if you just want to consider A goes to C here, A goes to C as well as A goes to D. Combine these both and write CET. A goes to CD. So it does not matter if I write C here, C goes to C, we need not write. That doesn't make any sense, right? So A goes to CD is the first one. Combine these both, common letters, combine, E goes to AH. That's all what you have to write here. A goes to CD, E goes to AH. That's the minimal cover. Okay. And the next question, 8th question, let's see what it is. This is the 8th question. In the 8th question, what we have? Given two functional set dependency, this is repeated 3 times. Along with that, first time I have written the question here. Along with that, 3 times it's repeated. Okay. So this is a functional dependency FD1 and this is FD2. You have to see if they are equivalent or not. See, in the previous problem only we find out this answer, that what we got, A goes to CD, E goes to AH. Directly we can say they are equivalent. But the approach what you will follow in the exam is that first you will do F is closure of G or not. F is closure of G or not. That's the first step. Second, G is closure of F or not. That's the second step. If both are closure of each other, they are equivalent. That's how you will solve the problem. So here I am discussing the how to find out the closure. Okay. So let's see, consider the LHS attribute here. Okay, so yeah, here. So these are two things, f and g is given here. Determining f covers g or not. F is the closure of g or not that we are determining. So in f we are starting from f covers g, so we'll be writing f here first. F goes to a goes to c. You got a here. What is the closure of a? A's closure is a goes to a goes to c, and ac goes to d. That's all. So I have written three things here. Next, e plus. Next I have the letter e. E goes to ad. So e goes to e itself, ad, and e goes to h. So I have written h here, and a goes to c. So I have written c here. So all letters I got. If I got all the letters here which are present in the main relation, then I can say that f covers g. F covers g is done. Same thing I'll do for the next one also. G covers f or not. A goes to ACD, E goes to EAHCD. Same thing what I did above, same thing you have to do in the reverse order. So you'll get the same thing. If you got both the covers as same here, then what you'll write is that they both cover each other and equivalent. Okay, that's how you find the closure. And the next one is about okay, question number 15. Let's see what is the question number 15. Okay, the question number 15 is consider the relation schema R is equal to A, B, C, D, E, F, G. Okay, I guess it's still f. Okay, a b c d e f, and the functional dependency. This is the relation given, and this is the functional dependencies. What is the primary key of this relation? That's the first question. What is the highest normal form? The second question. Preserving the dependency, decompose R into third normal form. The third question. Okay, this is the third type of question which could be asked. First one is minimal cover. Second one is about the closure property, question number 8. Third one is about this one, like finding out the primary key, highest normal form, decomposition of the third normal form, those type of questions. So let's see how to solve this type of question, and moving on to the answer part. So first I wrote here the relation, okay, and FDs are here, and the three questions which I asked is primary key, highest normal form, decompose R into third normal form. So what is a primary key? Primary key is the key which determines all the other keys. Okay, so let's go to trail and error method. So A goes to B. Okay, A goes to B, A is determined, B is determined. Now B goes to somewhere. No, B doesn't go to anywhere else. So I can't determine these things alone by A. So A is eliminated. B. How many elements can B determine? None of the elements, because B is not starting anywhere here. What about C? C can determine DF, and D can determine F. So all the letters which I have finally is D, F, and C. What about A and B? How will I determine that? That's not possible. Same thing for E and F. I will check. I'll not get anything because E and F are not starting from here. And what is left is yeah, after we have done for the single letters, if you don't get anything, then move to the two letters. Only if you don't get in the first letter, then only move to the two letters. In two letters, consider A, AB, AC, AD, AE, AF. Like that you have to consider. So let's see AB. If you consider both A and B, still we don't get anything because A goes to B and B doesn't go to anywhere. Still we remain with AB itself. So let's see AC. AC is the primary key. Okay, let's see how it happens. A, C. A goes to A. From A I got B. Let's consider C. From C I got D and F. So C is there itself. D and F also I got. And here I'm remaining with E. I can go with E also because AC goes to E and I have AC already here. So AC goes to E. I will be writing E here as well. Okay, so I got all the letters which are present in the main relation. Therefore, from which I got? From taking AC as the key. So AC is the primary key. That's all. Highest normal form. What is the first normal form? First normal form is there should be no multi-valued. So B is single, D and F is also single, E is also single, F is also single. What is meaning multi-valued is F has some other subsets also. Okay, it doesn't have any subsets. It's in the first normal form. What about second normal form? Second normal form, it is not there. What does second normal form say? It should not be partially dependent. Okay, so let's see the diagram and understand in a more better way. So yeah, we have got the candidate key AC because AC determines all the other keys. So we will be making a table here. A and C is the primary key. So I have underlined those A and C. Okay. So after that, what are the dependencies they have given? That I am writing. Okay. So what are the dependencies given to us? The dependencies are A goes to B, C goes to DF, AC goes to E, D goes to F. A goes to B. I'll be writing here. A goes to B. Then after that we have C goes to DF. So C goes to two things, D and F. And the next one is AC goes to E. So I have here AC. AC, both AC both go to E. Last one is D goes to F. Okay, D goes to F. I have written here D goes to F. Okay, so what is the second 2NF rule? 2NF rule is that we have to eliminate the partial dependencies. Partial dependency means here only A is going to B and C is left out. Both the primary keys should be going, like how we have for E. AC goes to E. This is the full dependency. If you have only one primary key which is going to some other key, that is the partial dependency. Wherever you get partial dependency, remember one thing: if you want to normalize it into 2NF, separate it. How you will separate? Just write here AB. A goes to B. Now in this table, we just have one primary key which is dependent on B. Like that, which is the other violation happening here? C goes to D and F. Here it's partial because A is not getting considered in the transition here. So I will have to separate C goes to D and C goes to F. C goes to DF. Also D and F are here. That doesn't make any difference because D is not a primary key, so it will not violate it. Okay. So C goes to DF I have written here. The third one is what is remaining. D and F are cut. B is also cut. Remaining is AC goes to E. So that's the final thing which I will write here. AC goes to E. This is in 2NF. Now can we make it into 3NF? The first question is it already in 3NF or not? Is it already in 3NF or not? It is not in 3NF. Why? Because C goes to D, okay, D goes to F. Two things are getting transitive. This should not happen. So the very simple thing what I will do is C goes to D and F. I will keep this separate here and I will take this into a separate table. What I mean is these two things I will keep it as same here. C goes to DF and D goes to F. I will take it as separate and I will make D as primary key. So this is in the 3NF. Okay. So that was about the normalization question under the inference rules type, and they could directly ask you to normalize the table as well, like in the 12th question here. In the 12th question, the question is what is the need of normalization? That you can refer to the PYQ video. Consider the relation employee project. How many attributes we have? SSN, P number, hours, ename, pname and P location. Assume these two are the primary key. SSN, P number, these two are the combination is a primary key and the functional dependencies are given to us. So the first thing what you need to make is the schema diagram, then we'll do the following normalization. So first thing what you have to do, make the schema diagram, right? So how will make the schema diagram? Two primary keys, the functional dependency one is given, SSN, P number goes to hours, that I have written. This is second one and this is third one. Now is it in 1NF? Yes, it is in 1NF because it doesn't have any subsets like pname, initial pname, final pname and all those things are not there. So it's the means in 1NF. Second thing is it in 2NF or not? Which are the primary keys? The primary keys are SSN and P number. This goes to both goes to R. So R is okay. What about ename? Ename is just coming from SSN. That's not valid. So we have to separate it. So we'll separate ename here, and the next one also it is just coming from P number, right? P name and delocation, it's not coming from SSN, only from P number. Therefore do the same thing, write it only from P number. Okay, so it's already in 3NF as well because I cannot find any partial dependency here. So yeah, that's all. It's in 3NF as well. So this is the final answer for the given question. Okay. So let's see the last one, which is lossless non-additive join property. So this rarely asked, means it is the least important among these three topics. So if you can skip this one, and if the question comes in OR, you can go for the other one. Okay, but it's pretty simple. If you see also, it will be helpful for you. Okay, so the question is this one. Consider the universal relation R is written here. How many letters we have? A to J. Okay, 10 letters we have, and the set of functional dependencies. These are the functional dependencies given to us. Now determine whether each decomposition has the lossless join property with respect to F. So what all things we have been given? The first thing is R is given to us. Second thing is functional dependencies. Third thing is the set of rules here. So the three things we will be writing. Okay, then I will be explaining you what all you need to keep in mind. Means how to approach the question. Okay. So first thing I wrote here R, what is given to me, I wrote here R. After that the D value also I wrote, means the third thing which I told in the few seconds when I told the third thing, right? The third thing is this one, second thing is this one, functional dependencies. After I have written this one, start from here R, A to J, write in the columns A to J. and how many R we have? R1, R2, R3, right here R1, R2, R3. Okay. Now what are the values here? How I wrote A and B values, I will be explaining. First let's focus on how to write the A values, later I will be telling how to write the B values as well. Okay, so you will be starting from here. For R1 A, this will be empty initially, right, after making the matrix. So observe one thing and tell me. R1 goes to A, B, C, D, E. So R1 goes to A, B, C, D, E. Okay, till here A, B, C, D, E. So in A, B, C, D, E, what you will write? A. You will start from A first. A1, 1 means first column. A2 means second column. A3 means third column. A4 means fourth column. A5 means fifth column. Cool, you have written this one A1 till A5. Okay, so after written that one, same thing goes for this one also. For now keep it empty here. Okay, and R2 B, F, G, H. So under B, F, G, H you will write A. B, A2 because it's the second column. B, F, G, H, whichever column number is there, write that along with A. Rest the things you keep empty for now. R3 D, I, J. So for R3 I wrote here D, A4, I, J, 9th and the 10th column. Okay, after you have to, written the A values, the B values is very simple. Only the thing you have to keep in mind is wherever you find the empty space, what you have to write? R1 is there, right? This is the which row? First row. Which column? Sixth column. B, first and sixth. Same thing here also. First row, seventh column. First row, eighth column. First row, ninth column. First row, 10th column. Same thing wherever you find empty spaces. Second row, first column, 2, 1. Second row, third column, 2, 3. Like that, fill all for B values. That's your first step. You have to fill all the values including A and B. Cool. And after that, what you have to do is the next step. In the next step, let me tell you, you have to see the functional dependencies here. How many we have? 1, 2, 3, 4 and 5. 5 functional dependencies we have to see and write the answer. Okay. So let's see how to do that. Here what we have is you have to eliminate the B values. Okay, so first start from here. AB goes to C. Okay, AB goes to C. Removing the B values, this is the initial matrix which you have. AB goes to C. So in AB, how many are there? A and B is there. A and B goes to which one? C. So in A and B, first what you have to check, is there 2A here and 2A here? Is there 2A here? No. Is there 2A here? Yes. But combination of these, we don't have 2A in both the cases, so we'll not do anything. Keep it as such. Okay. A goes to DE. A goes to DE. Does A have 2 A's here? No. So we'll not do anything. B goes to F. B goes to F. Okay. In B we have 2 A's. Yes. So if we have 2 A's in B, the same corresponding row and the column in F should have the same A value. Here initially we have put the B value if you look at the above table. Okay. So we need the same value. Same value means same value of A. A is same here. A should be same here as well. So cut B value and write here A value. So you will get there A6. You will cut this one and write A6 here from the bottom one. That's about the B goes to F and F goes to GH. After I have written F here, you have 2 A's here. Yes. F goes to GH. In GH what you will do? You have 2 A's here. So because of 2 A's what you will do? Goes to GH. Here the same thing will be happening. Here also it was different, you will make it same. Here also it was different, you will make it same. Okay. Cut these two things which are different here. Write the below things above. Why we are writing the below things above? Because these two are the same in F. F goes to GH. F has same A value. Make the same A value in the corresponding rows also. Means the column also. F goes to GH is over. Last is D go to IJ. If D goes to IJ, okay, D, where is D? Yeah, D is here. We have 2 A's initially. IJ, it goes to I and J. So you will have to make these as same. Cut the above B values and write this as same. After you have got the same, means all the A values in any of the row, that means it's what do you call? Yeah, it's lossless joint property is valid. Okay. What you will write is if all the A's in any row, it has the lossless joint property. Okay. That's about the lossless joint property, and these are the 3 algorithms which they could ask regarding each of the questions. The last question I discussed is this one. So the question that might be asked is this one. The algorithm you have to write, and if they ask the question you have to write the answer as well. So this is the second one, minimal cover, and this is the third one, closure properties, closure of X under F. Okay. So that was about the module 4. Moving on to module 5, we have the main question: is it serializable or not? Very simple topic. The question just looks like a bit complex, but it's very simple topic. Okay, so the first question is, so totally we have the 4 questions here. The 4 questions are also very similar. Let's consider the first question. This is the most repeated one. Okay, if you understand this one, means the rest three are also very simple for you. Okay, so what is the question which is given to us? Observe carefully here. Transaction T1, T2 and T3. How many transactions are there? 3 transactions. How many schedules are there? 2 schedules are given below. Draw the serializability graph for S1 and S2 and state whether each schedule is serializable or not. What we have to mainly do is it serializable or not? Serializable can only be applied to schedules. So we have to check S1 and S2 are serializable or not. So how do we check that one? At a time one will consider, S1 will consider first. So S1 what we have? This is given in question S1. How many transactions we have? T1, T2 and T3. So we will be first writing here T1, T2, T3. This is just for S1. After that, in the order you will write. Okay, R1x belongs to which one? T1. So it's very simple. R1 means 1 is there, that means it belongs to transaction 1. 2 means it belongs to transaction 2. 3 means it belongs to transaction 3. So even if these things are not given, you can directly derive from this one only. R1x is the first thing. So in S1, under S1 you will write under T1 because it's R1x first thing. Then in the second row, what you will write? The next thing which I have given, R2z. So R2 is the second column and Z you will write. The third thing what they have given, R1z. So the third thing you will write here, R1z in R1z. So in that order you will write everything here, one after the other. Make sure it's leaving one space and writing the next other thing. Like that we will write for all here. After you have done for that one, you have to see if it is serializable or not. How you will see if it's serializable? Okay, 3 things you need to keep in mind. How many operations are possible? Read read, read write, write read, write write. 2 things are only you can find, R or W. Okay, R2, R3, W1, W2, W3. That means read and write. And the resources on which the reading and writing operation is specified with this one. Read on operation X, read on Z, read on Z, write on X. That's the thing. Okay, that you need to keep in mind. Now after you have written this one, how to check if it's serializable or not? As I told you, 4 things are there: read read, read write, write read, write write. Okay, 4 things are there. Now the only thing which causes the problem is this these 3. Read on read is no problem. Read on write, write on read, write on write on the same resource, that causes the problem. So let's see where the problem is happening from. R1 is reading X. Okay, so after this point, where all you can find here, if you are considering this one, eliminate this one column here and see here where all the X is getting the means reading or writing operation. After this point here, in this point where all X is happening reading or writing, X is here, and yeah, that's all where X is. Now you need to check if it's read same operation. It is same operation, right? So nothing will happen. See what is happening here, read on the same resource, so no problem. Okay, so we'll move on to the second one. In second one we'll eliminate this one and we'll just consider this one and this one. What is happening? Read operation in which one? Z. So where all Z you can find, circle that one. First I can find here, and yeah, that's it. So here read and read, it's no problem. Then here again Z, and where all I can find here, the Z content, Z is found here. So what is happening? Write operation. So different thing, read and write. So when different thing happen, you have to make the graph. Okay, graph first you have to make T1, T2 and T3, and from where it is happening, from R1 till means this is T1, this is T2. So from T1 to T2 make a line, T1 to T2, and write there Z, because on the operation Z, read or write operation is differing. Okay, that was for this one. And let's move to the third one. Here in this part, where all you can find X, I found X here. Yeah, so T3 to T1, it is read on write operation, so we'll consider that one. T3 to T1, right here X. Then this one, can I find anything here? Read on Y, Y is here, read it's okay, read write differing. T3 to T2, T3 to T2 on Y. Next one, X here, do I find anything here? No. Then this one, do I find anything here? Yeah, W3 on Y, read and write. Okay, this is T3 to T2, T3 to T2 on which it is happening, y, right. So I'll be writing here y, T3 to T2, this is already done, so I'll not do anything. Then after this is over, then this nothing is left, so it's nothing. Okay, now after I made this graph, see if there is a cycle. Can you find any cycle here, like loop or something? No, this is not a cycle because it's going here and here and it's ending here. So if we find a cycle, it is not serializable. If we find a cycle, if there is a loop or something, we cannot serialize it. Okay, remember this point. Okay, if we find a cycle, we cannot serialize it. If there is no cycle, then only it is serializable. Okay, then in the same way we will do for the S2 as well. Do the same thing what I told for S1, write all the things in the schedule part here, and after that we will check if it's serializable or not. So since read on read it's not a problem, so I am skipping a read part here. So till this point it is just read and read. Okay, so I'll be just considering the bottom part here. So read one on X. Is there any write on X? No. So the next one is which one? Here, this one. Is there any Z getting changed here? No. What about X? Is any X getting changed here? Yes. T3 to T1 is getting changed here. So I'll make a arrow from T3 to T1 on T3 to T1 on X. That I have done. The next one is this one. Is it anything getting changed here? Yes. T1 to T2 on Z. T1 to T2 on Z. I have written here Z. After that, yeah, this one. Here I am getting any change? Yes. T2 to T3 on Y. T2 to T3 on Y. Done. After that, this one. Is it any change happening here? T3 to T2 Y. T3 to T2 Y. See, you got a cycle, you can stop it at there itself. So if you got a cycle like this, a loop here, so that means the graph has cycle, it is not serializable. That's all what you have to write. Okay, that's basically the serializable questions. You have to make the means write the in order and check if there is any cycle in the graph or not. If there is a cycle, it is not serializable. If there is no cycle, it is serializable. Let's see the second question, which is very similar to it. Check whether the schedule has means serializable or not. If there is the algorithm also, it's very simple. Let me explain the algorithm. That's a very same thing what I have told you. So for each transition, you have to write participating in the schedule as create a node table precedence graph. If it is read after write, then make an arrow. If it is write after read, make an arrow. If it is write after write, make an arrow. Three things I told, right, which makes the conflict. Read on write on read, and write on write. Read on read is not mentioned, so nothing. The schedule S is serializable if and only if the precedence graph has no cycles. If there is no cycle, it is serializable, else it is not serializable. It's as simple as that. Okay, so yeah, the second question, let's go through it quickly. So this is the thing which is given to you. Write in the same order how many transactions we have. R1, R2 is there, R3 is there. Yeah, R3. So 3 transactions I have to make here and write the table here. So the answer to that is here. So 3 things I will be writing here. Same thing, R1, R2 in the order I will write how they have given. I will check if there is any dependencies, I will make the graph, and if there is a cycle, so it is not serializable. Since there is no cycle here, it is serializable. And the solution to the third question, check whether the below schedule is serializable or not. Same thing we have to do here as well, and question 4 also we have to do the same thing. So you can refer to that for more information. Okay, so that's all what we have mainly in the module 5 and the module 2 and 3 as well as 4. So if you have any doubt, feel free to put the question in the means the DM me on Insta. If I get time, I'll reply to you. And thank you so much for watching. Make sure you subscribe and hit the like button, and I'll see you in the next one.